Radio antennas are behind almost every form of telecommunication nowadays. At a basic level, they work by sending out encoded electromagnetic waves by shaking electrons. But why do charged particles that are accelerated emit light in the first place? Say we have a stationary charge with a static field. It can be helpful to imagine the radial field lines coming out of this point charge. Now, if we accelerate the charge to the right for a short amount of time, this charge still carries its collection of field lines with it. But the field everywhere doesn't change instantaneously, which means that most of the field lines are actually pointing at the original location of the charge, even though it isn't there anymore. Near the charge, though, the field lines do point at the actual location. Still, we can't have any breaks in the field lines, which means there's a sort of transition region, where the field lines go from pointing at the original location of the charge to its current location. It's this blip in the field that goes outwards at the speed of light, and is our electromagnetic pulse.
We also have this man to thank for his derivation of what's now known as Larmor's formula, which is an approximation for the amount of power that is released when a charged particle suddenly moves. As you'd expect, this power and the characteristics of the electromagnetic wave that is radiated as a result are both directly related to the magnitude of the charge and acceleration of the particle. This principle is fundamental to so many human pursuits. See, accelerated charges don't have to emit just radio waves. With the correct conditions, almost every type of light across the spectrum is fair game. So, better understanding this phenomenon is crucial to everything from developing better X-rays to understanding the secrets of our universe. So the next time you're surfing the web or watching some TV, remember that all of this information is at your fingertips just because we know how to make the electrons in a piece of metal get groovy.